Welcome to YouTube channel Linga Reddy Chemistry JE NEET. Today topic is aniline, physical properties and chemical properties. Reactions due to benzene ring. In the aniline, NH2 group and benzene ring both are there. In the last video on NH2 group, whatever reactions are there, those reactions we discussed. Now today class we are discussing on the benzene ring, whatever reactions are there, we are going to discuss now. Before that, we had to know the resonance structures of aniline. In the aniline, nitrogen has one lone pair. This lone pair is donating to benzene ring. So here this NH2 group acting as plus mesomeric effect, plus mesomeric group. So it is giving electron to benzene ring. In the benzene ring, ortho position and para positions are getting more electron density. So NH2 is known as ortho para directing group. Ortho para directing group. That means कोई भी electrophile है, so this electrophile will attack either ortho position or at para position. This is decided by NH2 group. That's why NH2 group is known as ortho para directing group. Not only NH2, all plus M groups are ortho para directing groups. Note point here. In aniline 2, 4, 6, see numbering, I am giving 1, 2, 3, 4, 5, 6. 2, 4, these 2, 6, 2, 6, these are ortho positions. This fourth one is para position. In aniline 2, 4, 6, ortho and para positions are electron rich. So electrophile attack here in aniline third and fifth or meta position is electron deficient. So nucleophile attacks here. If nucleophile is there, nucleophile where it will attack? Wherever less electron density. So possibilities are there, third and fifth position. Electrophile will attack at 2, 4, 6 positions. Next, the benzene ring of aniline undergoes halogenation, sulfonation and nitration. The NH2 group is ortho para directing group. First reaction, halogenation. In the halogenation, chlorine and bromine react with aniline and form trichloro and tribromo aniline respectively. See here it is giving the white PPT. So this is also known as functional group test. So compound conformation के लिए, aniline conform के लिए we are doing bromine test also. See, in aqueous medium, this bromine is attacking on the benzene ring of aniline at ortho position, para position and ortho position. So 2, 4, 6 tribromo aniline, it is giving white precipitation. Even in case of chlorine also same. Suppose if you want only one bromine, monobromination चाहिए तो क्या करना है? Then you have to change the solvent. Solvent you have to change. Which solvent you have to take? Non-polar solvent you have to take. Then what will happen? This bromine decomposition will becomes less. The bromine Br plus and Br minus is forming less amount. In the ionic polar solvent में easily it can get separate Br plus and Br minus. Maximum Br pluses are there, that's why maximum attacking. But in non-aqueous, non-polar solvents, not non-aqueous, non-polar solvents, the bromination, the ionization takes place slowly. That's why this reaction takes place slow, only monohalogenation takes place. The non-polar solvents are here, you can see CS2 and CCl4 here. Polar solvents generally water. Okay, generally we are taking here aqueous. In aqueous, 3 bromines are substituting. In carbon disulfide and carbon tetrachloride, only 1 bromine is substituting. Note point. However, monobromo or chloro derivatives of aniline can be prepared if NH2 group is first protected by acetyl group, here the reactivity decreases due to minus I effect. So one more method is there. What we are doing here, now why in aniline 3 bromines are attacking or substituting? That is the main question here. See, already in the benzene we have 3 pi bonds, so electron excess. So nitrogen again giving electron density, so electron density is more. Electron density is more. Electron density is more. That's why more electrophiles are attacking. More electrophiles are attacking in the aniline. Okay, that is the thing. That's why what we are doing, we are protecting this NH2 group. We are doing first acylation. Acylation में this CH3 C double bond O plus the electrophile is attacking on the nitrogen. So see, like amide type formation is there. This acetonylide is forming. Now here lone pair is there. This lone pair 50% it can give like this. See, I am writing the structure here. The benzene ring NH C double bond O CH3. So it has a lone pair. This lone pair it may gives to this C double bond O also. Why? Because this pi bond shifted to oxygen. This carbon getting positive charge. So here benzene ring is there. So benzene ring also it can give. So 50-50%. So this aniline nitrogen is donating electron density to benzene only 50%. Here it is 100%, but here only 50%. So the activation of benzene ring is becoming less. Okay, that's why here only one bromine will attack on the benzene ring. Obviously that will be at ortho position as well as para position. Okay, after bromination, then just you do the hydrolysis, then you will get, we know that amide we discussed in the last classes, amide को hydrolysis करे तो ये carboxylic acid बनेगा, then NH3 बनेगा. ठीक है, if it is RNH, then obviously amine बनेगा. So like that. So similar explanation here. This here hydrolysis takes place, this NH2 is forming. So you are getting only monobromination. Next, nitration. The nitration, direct nitration of aniline yields 3 oxidation products in addition to the nitro derivatives. Moreover, in the strongly acidic medium, aniline is protonated to form the anilinium ion, which is meta-directing group. That is why, besides the ortho and para derivatives, significant amount of meta products is forming. In generally, ये plus mesomeric effect है. So ortho and para positions are activated. So generally, our expected product will be ortho and para products. But unexpectedly, this meta product also we are getting. Why? Means here resonance you can see. See, this NH2 is getting protonation first. I am writing here. This NH2 has a lone pair. Okay, it is taking H plus. Okay, so then the structure you can see here. Nitrogen is plus. So nitrogen plus means this is a minus inductive group now. It is a minus inductive group. माइनस इंडक्टिव ग्रुप में क्या होता है, दिस लोन पेयर, दिस pi bond is shifted outside, so here ortho position and para position getting positive charge. Okay, so here attacking is electrophile. Obviously electrophile in this case it will attack at meta position. That is the reason almost 50%. Okay, maximum meta product also forming, as well para product is forming. So due to the repulsion, ortho product is less. In generally always ortho product is forming less than the para. Okay, general होता है. ठीक है, हाँ एक्सेप्शन है, एक्सेप्शन वेन एवर हाइड्रोजन बॉन्ड फॉर्मेशन इज देयर, एक्सेप्शन ये है when exception when hydrogen bond forming when hydrogen bond forming is there then ortho is major than the para, वो फिनाल में होता है जनरली, ठीक है. नाउ so three compounds are forming in the nitration. Suppose if you want only single nitro group, then you had to same bromination में जैसा here also you have to protect this NH2 group. For that you have to do acylation. In that acylation case, this lone pair 50% giving to this side, 50% giving to this side. Okay, this NH2 is protected. So finally it is acting as plus mesomeric only. So para position and ortho position, para nitroacetonylide and para. Okay. By the hydrolysis we are getting para nitroaniline. Here ortho we are not getting because due to repulsions. Here steric hindrance is more, that's why we are not getting. Okay. By protecting NH2 group by acetylation reaction with acetic anhydride, the nitration reaction can be controlled and para nitro derivatives can be obtained as the major product. This is the major product. Minor product is there, ortho position, that is very less. Then sulfonation also similar. First in the sulfonation H protonation जैसा होता है, protonation takes place here. NH3 it becomes, after taking H plus, nitrogen becoming plus, then HSO4 minus is attacking here. It is forming like salt जैसा formation होता है, anilinium hydrogen sulfate. Then at higher temperature it is rearrangement takes place. So Preece rearrangement जैसा होता है. Okay, this sulfate is attacking at para position, that is called sulfonilic acid. Okay, this is the strong acid. Okay, strong acid means it will donate H plus, then it becomes SO3 minus. This H plus is taken by this base, it is the base, so it is taking H plus. So whenever in a single molecule anion and cation is there, those are known as zwitter ion. Same word it will come in the amino acids, in the amino acid also it will come zwitter ion. Okay, aniline does not, important note point, this one note point and important competitive exams. Aniline does not undergo Friedel-Crafts reactions, alkylation and acetylation due to salt formation with aluminum chloride, the Lewis acid, which is used as a catalyst. Due to this nitrogen of aniline acquires a positive charge and hence acts as a strong deactivating group for further reaction. If you use that aniline plus aluminum chloride in the Friedel-Crafts reaction, what we are using, aluminum chloride, so it is reacting directly with NH2 group, it is forming, see, NH2 here, positive charge aluminum chloride. So now it is acting as ring deactivated benzene. So deactivated benzene mein there is no alkylation or acylation. That is the reason it cannot take place Friedel-Crafts alkylation. This is important and a note point, star mark. This process is called baking. Sulfonilic acid is an important intermediate in the manufacturing of dyes and drugs. The compounds in which both proton donating and proton accepting groups present are called ampholyte, proton acceptor and proton donator. See here, proton donating, H plus donating here, this H plus received by NH2 group, so this is known as zwitter ion. So this is also known as ampholyte, dipolar ion. Catalytic hydrogenation. Aniline undergoes hydrogenation in the presence of nickel at higher temperature to form amino cyclohexane, amino cyclohexane. In generally benzene में hydrogenation difficult है, लेकिन it will takes place, okay, at higher temperature. So the benzene ring is forming like aniline, cyclohexane. The benzene is converting into cyclohexane, NH2 group as it is. Next, test of aniline. Carbonyl element test. This is the functional group test, carbonyl element test for primary amines. The aniline gives carbonyl element test or isocyanide test. Cyanide is Cn, isocyanide is Nc. Isocyanide test is a bad smell, foul smell बोलते. Carbonyl amine test. Only primary amines are giving. Only primary amines. Only primary amines are giving. So same reagent we learned in case of phenol. In the phenol chapter, it is giving Reimer-Tiemann reaction. Salicylaldehyde is the product. So named reactions important. Important named reaction. Next, dye test. Aniline is first diazotized on adding alkaline solution of beta-naphthol to the diazotized product. A scarlet red dye is formed. In the last video we discussed that equations. On heating with bromine water, a PPT is formed. Yeah, 3 bromines are attacking on the benzene and forming white PPT. Then uses of aniline. Aniline is used in the manufacture of dyes and dye intermediates, the manufacture of accelerators and antioxidants in rubber industry, the manufacture of acetonylide, sulfuric acid and indigo, the manufacture of sulfur drugs. From chlorobenzene, from phenol to aniline, phenol to aniline. These 3 questions are homework. Yes, homework. Acetylene to aniline, chlorobenzene to aniline, phenol to aniline. Okay, these 3 questions you solve it and share the answer. Bye. Thank you. Aniline chapter over.